नमस्कार बच्चों, मेरा नाम धन्या and today's topic in organic chemistry that we are going to learn is naming of polyfunctional group. So polyfunctional group means more than one functional group. So if any carbon chain has many functional group, the IUPAC naming we will be learning today. Okay, so first of all, want to tell you a rule that any carbon chain can only have one functional group. They can have only one primary functional group. Okay, there can be many functional groups, but only one of them can be the primary functional group. Okay, so one of them can be the primary functional group. So if there are more than one functional group present, then one will be the primary functional group, and the remaining spelling is wrong. Remaining functional group will become the substituent. Okay, so we will take an example for this, but before that, just wanted to tell that there is a priority order of different functional group. So the one which is above the priority order will become the primary functional group. The one that is below will become the substituent if the carbon chain is a polyfunctional group. Okay. For example, I will be discussing the priority order also, but before that, example. For example, the priority of this is the acid and this is alcohol. The priority of acid is greater than that of alcohol. Okay. And we learned that the suffix that we use for acid is oic acid, and the suffix that we use for alcohol is ol. Okay. So the priority of acid is greater than that of alcohol. So if we take an example over here, there is an acid and there is an alcohol. But according to the rule, only one of them can become the primary functional group. And according to the priority order, in this case, the acid is our primary functional group. Okay. So that means the alcohol has become what? The substituent. And if alcohol has become the substituent, we cannot use the suffix, because suffix means that is used for the primary functional group, and also suffix means that is used at the end of the name. So for the substituent, we use prefix. We have to use the prefix. And the prefix for alcohol is hydroxy. So here alcohol is the functional group, but here, because of the priority order, alcohol has become what? The substituent. And if it has become the substituent, that means we have to use a suitable prefix. For alcohol, the prefix is hydroxy. So in this case, the name of this compound, we have to number from the acid 1, 2, 3. And alcohol is the substituent, so we have to use a suitable prefix for it. So the prefix is hydroxy. So the name we use is 2-hydroxy. 3 carbon atoms, so prop, all single bonds. So propane, 1 oic acid. So this E I am removing. Okay, I hope I am clear. So there is a prefix for all the functional group if it is acting as the substituent. Okay, so we will be discussing the priority order. We will first discuss the priority order. And also we will discuss that when the functional group becomes the substituents, what are the prefix we use for different substituents. I hope I'm clear till here. So students, for the polyfunctional group, there is a priority order that we follow, and according to which there can be only one primary functional group. And if there are more than one functional group present in the carbon chain, the rest of it will become the substituent, as in this example that you see, alcohol has become the substituents. And for substituents, we use the prefix. And the primary functional group here is acid, because the priority of acid is more than that of alcohol. I hope I'm clear. So now we will discuss the priority order, and then we will discuss the different prefix that is used for different substituents. Okay. So the priority order goes like this. You can take a screenshot. Carboxylic acid is the first priority. Okay. COOH. Then next priority is sulfonic acid, SO3H. Okay. The next one is anhydride. This is the structure of the anhydride. The next priority is ester. Next one is oil halide. That means X represents the halide. Can be chloride, bromide, iodide, fluoride. Okay. Oil halide. The next priority is amide, RCONH2. The next one is cyanide, CN. The next in priority is isocyanide, NC. The next in priority is aldehyde, RCHO, CHO. Okay, the next in priority is ketone. The next one is alcohol. The next one is thiol. The next in priority is NH2. And the next one is epoxy. Okay, epoxy was discussed in the previous video. So this is the priority order. This priority order you have to memorize. Okay, so as you can see, so I have written it in order. So you can take a screenshot. Okay, so this is the priority order. Okay, so this is the priority order we will be following. Students, the next topic that we are going to discuss is the different functional group when they are the primary functional group, the suffix that we use, and if they are substituents, what are the prefix that we are going to use. Okay, so you can see the first one is acid. So if acid is the primary functional group, we use the suffix oic acid. Just a while ago, we discussed with an example too. And if it is acting as a substituent, or if it becomes the substituent, we use the prefix carboxy. The second one is sulfonic acid. So if the sulfonic acid is the primary functional group, we use the suffix sulfonic acid. But if it becomes the prefix, we use sulfo. So please take a screenshot. You have to memorize the name when the different functional group becomes the suffix, or the primary functional group, we use the suffix. And if it is becoming, or if it becomes substituent, we use prefix. Okay, so for different functional group, there are different names. Okay. Then the third one is anhydride. So anhydride, the suffix that we use for anhydride when it becomes the primary functional group is oic anhydride, and prefix it doesn't become usually. Okay. So please take a screenshot. Fourth one is the ester. So when it is the suffix, we use alkyl. When it is a suffix, sorry, alkyl alkanoate. Okay, so this is the suffix. If it is the prefix, we use alkoxycarbonyl. Okay, so once you memorize and when we practice different questions, it will be easy. Okay. The next one is acid halide. The suffix is oil halide. So halide can be, X can be fluoride, chloride, bromide, iodide, etc. So if it is chloride, we use oil chloride. And the prefix we use is haloformyl. Okay. The next one is amide. So if it's an amide, the suffix is amide and the prefix is carbamoyl. Okay. The next one is nitrile. We use the suffix nitrile, and if it is a prefix, we use cyano. Okay. The next one is isocyanide, and the suffix we use for isocyanide is isonitrile, and prefix we use is isocyano. Okay. The next one is aldehyde. The suffix we use is al, and the prefix we use is formyl and oxo. When to use formyl and when to use oxo will be discussed in the video when we practice some questions. Okay. The next one is ketone. Ketone. The suffix we use is on, and the prefix we can use oxo or keto. Any one of them we can use. Okay. The next one is alcohol OL. The suffix is ol and the prefix is hydroxy. We discussed in one of the questions before, one example in the video. The next one is thioalcohol. The suffix is thiol and prefix is mercapto. Okay. The next one is amine. The suffix is amine and prefix is amino. Okay. 14th one, the next one is epoxy. Epoxy usually prefix we don't use. Okay. So these are the different functional group, and when it is a suffix, what is the name we use, and when it is a prefix, what name we use is written here. Okay, so you can take a screenshot. So this is the acid. This is the sulfonic acid. This is, third one is acid anhydride. Structure of acid anhydride. The next one is the structure of ester. Fifth one is the structure of acid halide. Sixth one is amide. The seventh one is structure of cyanide. Eighth one is structure of isocyanide. Ninth one is aldehyde. 10th one is ketone. 11th one is alcohol. 12th one is thio alcohol. 13th one is amine. 14th one is epoxy. Okay, now let's practice some questions. Now the first question, students. Now you can see there are two functional groups. One is the OH, one is NH2, alcohol and amine. So if you look at the priority order, the alcohol OH is our primary functional group. So amine is our substituent. Okay, so we number from this side as it is nearest to the functional group, primary functional group. So what is the name for this particular compound? At the third position, when amine becomes the substituent, the prefix that we use is 3-amino. There are 4 carbon atoms, so butane, single bond, so butane. At the second position, alcohol, so it will get the suffix ol. So I remove this E because E and O coming near each other. Okay, I hope this is clear. Coming to the next question. CH3, CH, NH2, CO, CH, CH3, OH. Here you have a ketone, amino group, and OH group. There are 3 functional groups. So definitely the ketone is our primary functional group if you look at the priority order. And the amine has become substituent. Alcohol has also become substituent. Okay, so this is, so if amine has become substituent, the prefix we use is amino. If alcohol is a substituent, the prefix that we use is hydroxy. Okay, hydroxy. Now, the numbering. If we number from now amino and hydroxy, I mean the amine and the alcohol, both of them have become the substituent now. Now both are, you cannot say alcohol is more important or you cannot say amine is more important, no, because both are substituent. Okay, now numbering from which side? If we number from this side, 1, 2, 3, 4, 5. The primary function group is getting the third position. Now, if we number from the other side, 1, 2, 3, 4, 5. Here also the ketone, the primary functional group is getting the third position. Now, from which side we have to number? Now, because both amine and alcohol has become the substituent, substituent has nothing to do with the priority. Okay, priority is checked only for deciding the primary functional group. Substituent has nothing to do with the priority. Now, in this case, we number according to the alphabetical order. Okay, so according to the alphabetical order, amino and hydroxy. So amino can be given lesser number. So this numbering is okay. Okay, so priority is checked only to decide the primary functional group. Substituent has nothing to do with priority. Okay, so here at the second position, I have amino. At the fourth position, I have hydroxy. So both the substituents are of equal importance. And in this case, we check the numbering according to alphabetical order. We do the numbering according to alphabetical order. So that's why amino is getting the second position and hydroxy is getting the fourth position. And the priority is checked only to decide the primary functional group. So there are 5 carbon atoms. So pent, all single bonds. So pentane. At the third position, I have ketone, which is given the suffix -ome. Pentane 3-ome. I hope I'm clear here. Okay. Coming to the next question. So there is an acid here and there's a ketone here. So definitely the acid is our primary functional group. So definitely it is given number 1 position, number 2 position, this carbon, ketone, third position, and this is the 4th carbon. So ketone has become our substituent. So when ketone becomes a substituent, we use oxo. So at the third position, I have oxo. Keto also you can use, okay? 3-oxo, there are 4 carbon atoms, so but, and all single bonds, so butane, first position, oic acid. You may or may not mention the first position, and I am removing this E because E and O coming near each other. I hope I am clear here. Now, 2 questions I have given here. Now, in this question, suppose this is question number 1, this is question number 2, or case 1 and case 2. In case 1, here there is an acid, so definitely it is primary functional group because the others are alcohol. So alcohol will be substituent compared to acid. This is amino, that is also a substituent compared to acid. And then I have aldehyde also compared to acid. It is less priority group. Okay. So here for alcohol, we use the prefix hydroxy. For amine, we use the prefix amino because they are substituent. Okay. And we start the numbering from the primary functional group 1, 2, 3. Now, this aldehyde contains carbon atom. Okay. So we may or may not number it. For aldehydes I'm talking. So if I number it, it is given the prefix oxo. Okay. So in this case, the name of the compound is, we name it according to alphabetical order. At the second position, I have amino. 3-hydroxy. Hydroxy. 3-hydroxy, and at the fourth position, I have oxo. There are 4 carbon atoms, but with single bond butane, 1 oic acid. Okay, so this is 3-hydroxy. Now coming to case 2. In case 2, this is the acid, so that is the primary functional group. Aldehyde, that will become our substituent. Here also there is an acid. So numbering 1, 2, 3, 4, and 5. Both the side has acid. From either way we number, aldehyde will get the third position. In this case, you can see the aldehyde is the substituent, but we cannot number it. So in this case, if we cannot number the aldehyde, then we use the prefix as formyl. So if we are able to number the aldehyde, we use the prefix oxo. But if we are not able to number it, we use formyl. Okay. So the name of this compound will become 3-formyl 5-carbon, so pent or single bond pentane 1,2-dioic acid. Okay, so if we are able to number the aldehyde, we use oxo. If we are not able to number it, we use formyl. Okay, coming to case 1 again. This aldehyde, we can number it, or we cannot number it. So it's up to us whether we have to number it or not. We can refrain from numbering also. For example, I don't number it. Okay. So if I don't number it, suppose in the exam, we don't get this option. We don't have this option. Okay, so that means they have not numbered it. So it's up to us whether to number it or not. I'm talking about the aldehyde. Okay, because it's a substituent. Okay, so if they don't number it, we can use formyl. Okay, so our alternative name here can be what? At the second position, rest is the same. I mean the rest substituents. Second position, I have amino. At the third position, I have hydroxy. And because we are not numbering this aldehyde, and this carbon of the aldehyde is connected to the third carbon atom, 3-formyl. We have only 3 carbon atoms now in the main chain, so prop, all single bonds. So propane 1-oic acid. I'm removing this E. So I hope I'm clear. So in the exam, if you don't get this option, look for this option. That means they have not numbered the carbon of the aldehyde substituent. So that is why there can be the alternative name over here in which they have not numbered the carbon. So if you number the carbon of the aldehyde, we use the prefix oxo. If we are not numbering it, we use formyl. So I hope both the cases are clear. Okay. Coming to the next question. This is the alternative name. I hope you have noted down. Suppose you have a question, CH3, CH2, 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 CO, O, CPH5. C triple bond in cyanide group. Okay. Now, in this case, this is the ester, which is our primary functional group. And this is our substituent cyanide. Okay. So it is cyano. Okay. Now, this is a substituent cyanide group is the substituent. There is a carbon atom. We usually don't number the carbon of the cyanide. Okay. So we start the numbering from the primary functional group because it already has a carbon. 1, 2, 3, 4, 5. Do not number the carbon of the cyanide group. Okay. So primary functional group is the ester group. We use the suffix alkyl, alkanoate. Alkyl alkanoate. And which alkyl group is over here? Ethyl. So ethyl alkanoate. Okay, so what will be the name? Don't use cyano first, because whenever you are naming the ester, first the alkyl group comes over here. So ethyl, then the name substituents. At the third position, I have cyano. There are 5 carbons, so pentane, OH. So always write down the name of the alkyl group first, then the substituent, and then alkanoate. In this case, it is pentanoate because there are 5 carbon atoms. So this is an information about the ester group. So this you have to follow when you are naming the ester. Whenever you are naming the ester, first write down the name of the alkyl group, then the substituent, then the long chain carbon atom, the number, and then OH. Okay, so you may or may not mention the first position. The ester is at the first position. I hope I'm clear here. Coming to the next question, you can see this is an acid halide. It is acid chloride because there is a chlorine halogen. Now this is cyanide, so definitely it is the substituent compared to acid halide. So if it is a substituent, we use the prefix cyano. Okay, so numbering from the primary functional group, which is acid halide, giving the carbon number 1 position and number 2 position over here. Now, here cyano group has a carbon atom. Am I supposed to number the carbon atom? No, I'm not supposed to number the carbon atom of the cyanide group because it is a substituent. So cyanide group is connected to the second carbon atom. So whenever the cyanide group is acting as a substituent, you will not number the carbon atom. So at the second position, I have cyano. There are 2 carbon atoms, so eth, all single bond, ethane. And for acid halide, the suffix that we use is oil halide. Okay, so ethane, oil. What is the halide over here? It is chloride. So ethanoyl chloride. So this is the oil halide is the suffix that we use for what? For acid halide. Okay. The next question, you have an acid group, you have a cyanide group, you have acid halide, and you have aldehyde. So definitely the acid is the primary functional group. So this is given number 1 position. So 2, 3, 4, 5, and the aldehyde group, you may or may not number it. Okay, so aldehyde, it is, if you can number it, better to number it. Okay, and when cyanide is the substituent, we use cyano. When acid halide is the substituent, we use the prefix haloformyl. In this case, the halogen is chloro, so we use chloroformyl. And aldehyde is, because it's numbered, we use oxo. If it is not numbered, we use formyl. Okay, so at the 4th position, we name it according to the alphabetical order. So 4th position, I have chloroformyl. Second position, I have cyano. At the there are 6 carbon atoms. So hex, all single bonds. So hexane, oic acid. So you may write hexane 1-oic or acid also. It's up to you. Okay, I hope I'm clear here. So coming to the next question. So here there is an acid. So here there's an acid, here there's an ester. Here's an acid. Here there's an acid halide. So definitely the acid is the primary functional group. And ester is the substituent. Acid halide is also the substituent. Now, if ester is the substituent, we use alkoxycarbonyl. Alkoxy alkoxycarbonyl. In this case, the alkyl group is ethyl group. So ethoxycarbonyl. And when acid halide is the substituent, we use haloformyl. So in this case, the halogen is bromine, so we use bromoformyl. So the numbering starts with the acid carbon 1, 2, 3, 4, 5, and we don't number the carbon of the acid halide. We don't number it. Okay, so the acid halide is connected to the 5th carbon atom. So the name that we write is, writing it here, and name is written according to the alphabetical order. So 5 bromo formyl, 4 ethoxy carbonyl, 5 carbon atoms, so pent, all single bonds. So pentane, 1 oic acid, or you may just write oic acid. So this is the name. Coming to the next question. So we are doing different types. Okay, so almost we have covered many types. Now, NH2, CONH2. This is cyanide group. So here you have an acid, sorry, you have an ester here, CONH2 amide, which is a substituent. Here also, this also is a substituent. Okay, CONH2. Okay, so this is also a substituent. Now, amide is a substituent, and this is the substituent cyano. Okay, because compared to ester, the amide and the cyanide, they are substituents. So ester is the primary functional group. So if ester is the primary functional group, then it is given the suffix alkyl, alkanoate. And what is the alkyl that is here? That is phenyl. It is not benzyl, one hydrogen removed from the carbon atom, from the benzene ring. So that is phenyl. So always whenever we are naming the ester, first we write down the name of the alkyl group, that is phenyl. So first starting with the numbering, 1, 2, 3, 4. We don't give number to the carbon of the amide. Okay. So if amide is the substituent, and if the prefix that is used is carbamoyl, here also carbamoyl, and here it is cyan. Okay, so first, whenever we are naming the ester, which is the primary functional group, we write the name of the alkyl group. Here it is phenyl. So phenyl. At the third and the fourth position, I have carbamoyl. So di-carbamoyl. Second position, I have cyano. There are 4 carbon atoms, so bute, all single bonds, so butane, O8. So always whenever the ester is the primary functional group, we write the name of the alkyl group first, and at the end we write O8. Okay. Now, practicing some more questions. We have almost tried to practice different types. Okay. Coming to the next question. ClCO. Coming to the next question, you have an aldehyde group. You have the acid and you have the acid chloride. So definitely the acid is the primary functional group. The aldehyde is the substituent. The acid chloride is also the substituent. So when acid chloride is the substituent, we use, in this case, because the halogen is chlorine, we use chloroformyl. The prefix is chloroformyl, right? And the numbering starts from the acid 1, 2, 3, 4. We don't number the carbon of the acid chloride. Okay, so this is acid chloride. We don't number the carbon of the acid chloride. Okay, and in this case, the aldehyde is not numbered. Because it's not numbered, we use prefix formyl. Okay, so naming according to the alphabetical order, the fourth position, the fourth carbon, to the fourth carbon is connected the carbon of the acid chloride. Okay, so this is the acid chloride. So at the fourth position, I have chloroformyl. At the second position, I have aldehyde. So two formyl. There are 4 carbon atoms, so butane, oic acid. You may or may not mention the first position because acid is at the first position. I hope I am clear. Now, this is the answer. Coming to the next question. Here there is an acid. There is a bromo group. There is an aldehyde. And there is a methoxy group. So our acid is the primary functional group. So starting the numbering from the acid carbon, 1, 2, 3, 4. We may or may not number the aldehyde carbon. So if it is numbered, we give the name oxo. Okay. So at the naming according to the alphabetical order, so 4 bromo, then we will do the numbering in both the ways because we have numbered it here, numbered the carbon atom of the aldehyde, we use oxo, 5 oxo. Then third position, I have methoxy. There are 5 carbon, so pent, all single bonds, so pentane oic acid. Okay, and alternatively, if I don't number it, I remove the numbering and I don't number it. So alternate name, because in the choices, if they don't number it and write the name, then it would become what? 4-bromo, 4-formyl, because if I don't number the aldehyde carbon, it becomes formyl, 3-methoxy, butanoic acid. I hope I am clear. Okay. And one small mistake that I made is if I'm numbering it, I write it oxo, but the alphabetical ordering is not same. See? So here, if I'm numbering it, I write it as 4-bromo, 3-methoxy, because I have to name it according to the alphabetical order. 5-oxo, pentanoic acid. Because this was not according to the alphabetical order. This is according to the alphabetical order. So when do I use oxo for aldehyde? When I number it. When I don't number it, I use the prefix formyl for aldehyde. I hope I'm clear here. Coming to the next question. In this case, you have the aldehyde, you have ketone, okay, you have chloride group, you have methyl group. So definitely the aldehyde is the primary functional group. So here ketone has become the substituent, so it is oxo. This is chloro. This is methyl. So what would be the name? The name is naming according to alphabetical order. So numbering it 1, 2, 3, 4, and 5, 6. Okay, so here we number the carbon of the ketone. Okay, so wherever possible, if possible, you can number the carbon of the aldehyde and ketone. So at the third position, I have chloro. We are naming according to the alphabetical order. So 4-methyl, 5-oxo, 6 carbon atoms. So hexane, all single bonds. So hexane, 1-al. So I'm removing this E because E and A coming here near each other. Okay, I hope I'm clear here. Okay. Coming to the next question. Here you can see there's an acid group, there's an ester group, there's an aldehyde group, there's a cyanide group. And here, this is cyanomethyl. So here, just like CH3Cl, this is chloromethyl, right? Chloromethyl. Same way, CH3CN, we write it as cyanomethyl. So this is cyanomethyl substituent. Okay, so aldehyde is the primary functional group. So this is 1, 2, 3, 4, 5, 6, 7, 8. We may or may not number the aldehyde. By now, you know, if you number it, you write oxo. Okay. So here, when the ester is the substituent, we use alkoxy carbonyl. Here, what is the alkoxy group? It is ethoxy carbon. Okay, now we now name it according to the alphabetical order. 6-ethoxy carbonyl. At the third position, I have cyanomethyl. Then at the 7th position, I have cyano. 9th position, oxo, because I have numbered the aldehyde. There are 9 carbon atoms, so non, all single bonds, so nonane, oic, nonane 1-oic acid or nonane oic acid. Okay, so these are some of the examples of polyfunctional group that are present in the carbon chain. So that's all for today, students. Thank you.